Hey class, today we're going to look at section 12.2, which is graphing exponential functions without any transformations. We're also going to talk about the difference between growth function and a decay function. And then in the next lesson, the next part of this lesson, 12.2 part 2, we'll be doing some word application problems. All right, so let's look at our basic format for an exponential function without transformations is going to be this format here, f of x equals b to the x. B is what we call the base, and x is an exponent. Now, the growth function is if b ends up being greater than 1. If you have a number as your base greater than 1, it'll be exponential growth. It'll be decay if b is less than 1, but also has to be greater than 0. If you have a negative base, then it does like a really funky thing, and it does not really represent an exponential function. So we want to make sure our bases are greater than 0, and then we've got an exponential function. All right, so let's look at graphing. So our first example is just going to be 2 to the x, y equals 2 to the x. We can start by making an xy table to explore what this looks like. We can start with just kind of basic x values, -2 to 2, and then we plug them in. So 2 to the -2 power, 2 to the -1 power, 2 to the 0, 2 to the 1 power, and 2 squared. Some of these you'll probably be easier than others. 2 squared is 4, 2 to the 1 is 2. Anything to the 0 power is 1, so 2 to the 0 is 1. And then recall that negative exponents, x to a negative b exponent is 1 divided by x to the b exponent. So if I have 2 to the -2, that's the same as 1 divided by 2 squared, or 1/4. 2 to the -1 is 1 over 2 to the 1, which is 1/2. So that negative exponent kind of creates fractions for us. All right, and then if we plot these on the graph, if x is -2, y is 1/4. So it's going to be about right there. -1 is 1/2. 0 is 1. I want to mark at least a couple things here on my graph so I know what my scale is. 1. I'm going to go up to 2, and 2, 1, 2, 3, 4. I could do 3 if I wanted. 3 squared is 9. 4, 5, 6, 7, 8, 9 would be like all the way up here. So you can see this thing grows really fast. If I kept going in the negative direction, it would just become fractions that are smaller and smaller and smaller, but they would remain as positive fractions. So if we graph that with that in mind, this just keeps getting smaller and smaller, closer to that horizontal axis, closer to where the y value is 0, but it never actually touches it, which creates what we call a horizontal asymptote. So on our graph, we always want to graph asymptotes if they exist. And in this case, because as our graph approaches negative, as x approaches negative infinity, let me just write that out, as x approaches negative infinity, our function approaches 0. And that behavior there turns into what we call the horizontal asymptote. So if I asked you for the horizontal asymptote here, it would be the line y equals 0 because of that end behavior on the left side of our graph. This is a growth function because as x grows, so does y. And we could do domain and range really quick just to make sure that we've got all our pieces here. Domain of any exponential functions are just going to be all real numbers, or -infinity to infinity. And our range, if you notice, the y values are all above 0. So you can say that it goes from 0 to infinity, or you can say y is greater than 0, whichever format you prefer. So there's an example of a basic growth function. In your homework, I think your base, so our base in this case, b equals 2, and in your homework problems, I think you have some decimals, so just use your calculators to find the exponents for those bases that are decimals. All right, let's look at one more example here. So we have f of x equals 1/3 to the x power. So again, we can use an xy table to just kind of figure out what this looks like. I'm going to stick to my basic x values. So I have 1/3 to the -2, 1/3 to the -1 power, 1/3 to the 0, 1/3 to the 1 power, and 1/3 squared. When we are taking fractions to exponents, so a over b to the x, recall, this is a to the x over b to the x. So you just take the exponent to the top and the bottom. In this case, my numerator is 1, so that doesn't really make a difference, but 1/3 of the 1 power is 1/3. 1/3 squared is 1 over 9, or 1/3 times 1/3. Anything to the 0 power is 1. Now, what happens when you have a fraction with a negative exponent? A over b to the -x. We can flip the fraction over. It becomes b over a to the positive x. So 1/3 to the -1 becomes 3 over 1 to the positive 1. 1/3 to the -2 becomes 3 over 1 to the positive 2. So we can see those, the y values are actually growing as x gets smaller. And this is what creates our decay function. As x gets bigger, y gets smaller. So it has that inverse relationship. All right, so let's graph these. So when x is -2, it's all the way up at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is all the way up there. Let's just mark that. Oops, I'm running out of room. All right, when x is -1, I'm at 3. 0 is at 1. 1 is at 1/3, which is about right there. Then we go down to 1/9. So this is getting pretty small pretty fast. As x increases, those fractions are just going to get smaller and smaller, closer and closer to 0. Which creates another horizontal asymptote. And I made a little mistake there. Please excuse my sloppiness. All right, so again, now this one is a little different. Our horizontal asymptote is still going to be y equals 0 because that's the y value that my graph is approaching, but it's actually approaching it on the other end. So as x approaches positive infinity this time, our f of x is approaching 0, which creates that horizontal asymptote. So my horizontal asymptote in this case is still y equals 0. It'll change when we start doing transformations, moving this thing up and down. But for right now, it's still y equals 0. My domain and my range actually have not changed either. So all real numbers for my domain. My range is still y values greater than 0. But now we have a decay function because our base was 1/3. It was a value less than 1, but greater than 0. All right, and that's it for the basics of graphing exponential functions.